Hello again, Tom from Every Step Calculus, everystepphysics.com. Keep in mind, you just can't put index 8 in here in my programs. You have to buy my programs, first. I get some messages from people that said that they put index 8 in there and nothing happens, so which is true, but you have to buy my programs, and then you get instructions on how to do all this and to pass your calculus or physics, okay? This is a kind of a physics problem, but they're using calculus to solve it. And you can read it here. A spring has a length of 13 inches and a force of 11 pounds. Pressure is applied to compress the spring by 3 inches. However, an additional 2-inch compression is then applied. Use calculus to find the amount of work it took to compress the spring by the additional amount. So let's do that. Generally in my programs, like for instance in physics, when you see anything with a spring in it, you're going to go to spring in the menu. So let's do that. Spring, I'm going to go, actually I also have in here work of spring, so they want to find the amount of work, so here's work of a spring here. I pressed up here, which went to the bottom of the menu. There's 180 items in the menu, so it's quite a ways down. In your calculator, you can hold the second button here down and press this. It goes screen by screen, goes really fast down to the menu and up in the menu, okay? And in a test or something, we need to know these kind of tricks to really do things quickly and efficiently and fast. So at work of a spring, we're going to press, and then we're looking for a spring has a length of 13 inches. Normally, for your information, a natural length of a spring is really called L in all the engineering books and in physics and everything else, called just plain L, capital L. And so you're looking for L, and you're looking for a force, which is capital F. And then, of course, anytime you're compressing or a spring or stretching it, in physics it's called X, X1 and X2, depending upon which one you're using. So we look for that in the menu. Here's force and length and X1, X2 right here, number 4. You can scroll to it with this, or you can press the number 4 here. So here's a hurdle spring. Find the work done on additional compression, okay? We're going to enter the length. You have to press alpha before you enter anything into my entry lines here. So it's going to be alpha 1, 3. And it's in inches. And we're going to put in the force, alpha 11 pounds. We're going to enter the first compression, which is 3, alpha 3, and then alpha 2. I always show you which you've entered so you can change it in case you made a mistake, but this looks pretty good to me, so we're going to press OK. Now I tell you that natural spring of the length is not used in this calculation, so physics teachers and calculus teachers, they love to throw you off to really make you think deep upon the problem. Normally you'd think you'd have to do something with the natural spring. It's 3 inches shorter, so how much is the length of that and stuff, but not in this case, okay? So we're going to use Hooke's law here, which is the force is equal to the spring constant and the distance of stretch or compression. So we use algebra to find K. K is equal to the f of x divided by the compression, which turns out to be 11 over 3, okay? So we change the function because we're always dealing with functions in calculus. That's 11. K is 11 over 3 times x, okay? And the work is the integral of a and b over the function, and the function is k of x, spring constant in the compression, and dx with respect, you know, we're going to integrate with respect to x. We put in the limits. The limit is 3, and then you notice when you add 3 and 2 you get 5. So in calculus we have is 3 over or 5 over 3 for the limits of integration. And here's the k and the x, okay? Now also in calculus, any constant comes out of the integral, okay? So here's the constant out. 11/3 is out of the integral. Okay. Now we're going to integrate. We're going to integrate x, which is x squared over 2, and the limits are 5 and 3. Here's 5 and 3, and we're going to use, you know, for the limits, and we're going to bring that constant out here, the half out. Turns out to be 11 over 6 times x squared over 5/3. Then we integrate over each one of these limits. 5 turns out to be 45.8. We're substituting x in here. And here's 3, substituting 3 in, turns out to be 16.5. Always upper minus lower equals 29.3 joules. So that's the answer to this problem. Pretty neat, huh? everystepcalculus.com. Go to my site, buy my programs, and pass calculus. I'll also help you, you know, when you buy my programs, I help you with calculus or I help you with the programs. You can send me your quizzes, whatever. I'll show you how to do them on with my programs and help you all I can. Remember, I went through this 20 years ago when I was in electrical engineering and designed this program and this system, the only one I know of. And to pass my algebra, or not my algebra, but I mean my calculus and my physics classes. So anyways, good luck in your programs, and you know, I'll help you all I can. Have a good one.